start this off here with going to all the people who are not here. So how about Braylon? Help me on this first one. What is this even saying to do? And what would that give you? 3 of these tricycles. And some of you are probably like, wait, is this a trick question? This seems too easy. No, this is what we're doing, okay? So 1 bike plus 2 bikes is 3 tricycles. Jade, what's this next one? 2 what? We take 3 minions minus 1 minion. We have 2 minions. What are their names? You don't know the names of any minions? Bob, Larry, Stuart, or Dave. Those are all good names, right? Okay, let's go to this next one here. Emily, what about this? What's going on here? Well, what's this? What's this? Can you combine those? 3 what? So I guess you could say they're all balls, right? This is a football and that's a football, right?
Football.
But are they the same? So what do we do if they're not the same? Just let it be, right? It's kind of like this next one. If we got 5 Nemo minus a Cody Maverick, what do we do? You guys know Cody Maverick?
No.
Surfs Up. It's like the best movie about surfing penguins out there. So
Not even like half.
the point is, are they the same?
No.
So let's just let it be. Okay, this seems really juvenile. I heard some of you were like, this is what we do in preschool, right? This is what my kids are doing in school right now. Yeah. That's what you said, right?
No.
No, whatever. Now,
That's what you were
that's all we're going to do with adding and subtracting radicals. This looks a whole lot scarier, but really you're just looking to see, okay, which of these are the same? So put a little note up here. To add, you need the same index. Remember, the index is what tells you if it's a square root or a cube root. That needs to be the same. And you need to have the same radicand. That's the thing under the square root. So what I'm going to do, I'll show you this first one, okay? I'm going to look at this and say, okay, here's 1 square root of 2. I want to add that with 3 square roots of 2. Are they both square roots? Yes. Is the radicand the same? Is the thing under the square root the same? If the answer is yes, then you just add their coefficients. I have 1 plus 3, which is what? 4 square roots of 2. Just like when I had 1 tricycle plus 2 tricycles, that's 3 tricycles. 1 square root of 2 plus 3 square roots of 2 is 4 square roots of 2. They just have to be the same. Alright, let's go to this next one, okay? This is going to look a little scarier here, Emma. But the question is are they the same? Yeah, they're both square roots, right? And I've got the square root of 2xy and the square root of 2xy. So can we combine those? What would it combine to, Emma? So, yep, 3 plus 2 is 5, and then we just keep the radical the same, square root of 2xy. Nice job. Okay, let's jump down to this next one here. We're going to send this one to Mindy. Can you combine those?
Yes.
How come?
Because they have the same index and the same radical.
Radicand. So in that case, you just combine their coefficients. What would you get?
Negative 3.
Negative 3.
Cube
Cube root.
of 7.
Good job. Okay. Let's do this next one here, guys. This one looks super scary, right? Cube root of 7x squared z. But it doesn't matter how scary looking it is. If you're adding and subtracting, you're just checking, are they both cube roots? Yep. Or is the part under the square root the same? So then what do you do with our coefficients? Just subtract it. We're going to do 6 minus 3 is just 3. So this will be 3 cube roots of 7x squared z. Now, let me show you, this next one is where people, they start to mess up. They'll look at this and say the square root of 2 plus the square root of 3 is the square root of 5. Is that what we said to do? You can only add them if they're both square roots. Hey, they're both square roots, but is this part the same? In that case, you can't combine them. This is going to be like adding a football and a basketball. They're not the same. So then what do? We're just going to let it be. I'm not even going to do it. I'll just write it as square root of 2 plus the square root of 3. You can't combine them. Okay? Now, this last one, hey, look, the radican's the same. It's x squared and x squared. So can we combine those?
No.
Why can't we combine this here? That's a cube root, and this is a fifth root. So not only does a radican need to be the same the index does, so on this one we can't do anything, so I'm just going to rewrite it how it is. It stays the same. Okay, so that is how you add. So again, what do you need to have the same? The index and the radicand. Okay? When I go to this problem, you're going to look at this and say, hey, not the same, can't do anything. This is where I'm going to add in a little note. You always need to simplify first. Let me just show you a couple of examples of this. We're going to end with adding and subtracting, but we need to simplify first. And we got that. So for example, is there anything I can do with this 3? I break it down as 1 and 3. Do they have any buddies? No, but let's look at 2 square roots of 12. I want to come over here and say, let's look at 2 square roots of 12. Guys, what numbers give me 12? 3 and 4, and I can rewrite 4 as 2 and 2, right? So this is 2 square roots of 2 times 2 times 3. Alright, so help me out on this one, Oscar. Do I have buddies?
Yes.
Who are the buddies? What happens when they try to escape? Now, there's already a 2 out there, right? So what does the 2 that get out, what does it do with the 2 that's already there? We're going to multiply. So 2 times 2 is 4 square roots of 3. So originally when we looked at this, guys, we're like, oh, you can't add those together because they're not the same. Well, after I simplified them, I've got 2 square roots of 12 is the same as 4 square roots of 3. Now that I've simplified, can we combine those? They're both square roots. The radicand is both 3. So what's 4 square roots of 3 minus 1 square root of 3? 4 minus 1 is 3 square roots of 3. Does that make sense how we did that there? So before you just say they're not the same, you can't do anything, you actually need to take a step back and simplify it. So on this next one, I have the square root of 27, the square root of 18, the square root of 2. Nothing's the same to begin with, but maybe they will be the same once we simplify. I'm going to take this half of the room. You guys, simplify square root of 27. Jailbreak it. This half, you guys are going to simplify square root of 18. Then we'll see which of these can combine, or if they can combine all of them, okay? So you guys have 27, you guys have 18. I'll give you 30 seconds to try to break that down. Alright guys, so let me come to my square root of 27. What did you guys simplify this to?
You did that one wrong. It's 3 instead of 2.
Which one did I do wrong?
18 instead of 2
Oh.
squares, it's supposed to be 3.
Good job. You know, I was actually testing to see if you guys were paying attention. So good job. No, I'm kidding. I messed up. Okay, so this one should be 3. Is that what you're saying? So change that to 3 times 3 times 2. Awesome. Okay, so for the 27 group, what did you guys get it simplified to? 3 squares of 3. For you, the square root of 18 group, what did you guys get? 3 squared root of 2. And then lastly, we have a square root of 2 just hanging out, okay? So then, which of these can we combine? 3 squared root of 3 plus 3 squared root of 2 plus 1 squared root of 2.
3 square root of 2 plus square root of 2.
There we go. So I'm going to rewrite this one like that. So then what do I do with the 3 squared root of 3? It just stays itself. And we'll combine here. 3 plus 1 is 4 square roots of 2. Okay, that's where we're going to pause for today. Let me go hand out your assignment.